All right, we're back. Recording? Okay, yeah. Let's take a look at exercise 8. So an integral to represent the area between y is equal to x squared minus 3x plus 4 and y is equal to 2x. So if we just do a quick sketch of these things without drawing in axes, I find sometimes the axes to be disorienting for these. But take a look at this. This is a x to the highest power is 2, parabola. If you do a second derivative of this in your head, you'll see you get a positive number. So concave up parabola. Right? This shape is like morally like that. Here, y equals 2x is a line. So what's slope 2? So something like this, we're trying to find probably a region that looks like that. Right? And so in the shaded region, you'll note, let me blow up this picture quite a lot just to try to illustrate the point. So here, it's like, I feel like we need a happy face. But in the shaded region, if you're a point in this region and you move up, you'll find that the upper boundary of the shading is given by the line. If you start at the same point you move down, the shading, sorry I didn't shade very well, ends on the parabola. So I can already tell you now that we're going to set up an integral that's going to be integral of the formula for the line minus the formula for the parabola. This minus that. That's how the integral is going to be set up. Right? So the area is going to be given by integral the line 2x minus the parabola. There's multiple terms, so parentheses not required here, but here required. Yeah? So minus quantity x squared minus 3x plus 4 dx. But if this area, we're going to need the numbers because right as written, this is not it. Right? We need where does it start? So it's like here, you know, on the x-axis, I don't even know if the picture's up here or down there, right? But like, what number is that? And then here as well, what number is that? And that, so the x-coordinate here and here is not about the shading. It's not about the shaded region. It's just where does, we'll just redraw, right? So it's a question of where, this point and this point, there's an x-coordinate here. Of course, there's a y-coordinate, but I don't actually need that. So this x-coordinate here, x-coordinate, what is it? What are those? And to find, we'll just set those equal. That's what we need to do. Right? So we'll have here setting the y is equal, x squared minus 3x plus 4 is equal to 2x. How about subtract 2x on both sides? X squared minus 5x plus 4 is equal to 0. This, I hope, factors nicely. Two numbers that multiply to positive 4, add the two numbers, get negative 5. So x minus 4, x minus 1. Aha, so x equals 1, or x is equal to 4. Smaller x value here, 1. Bigger x value there, 4. Okay, that's the area between these two curves. At least setting up the integral. Of course, we could go through the integral, but we just, in the previous part, looked at lots of integrals. Let's take a look at number 9, exercise number 9. It's another area between problem, but this one's kind of sideways, I'd say. So exercise number 9. So we got, let's see, area between x plus 3y equals 2, x equals 12 minus y squared, and the lines y is equal to negative 1, y is equal to 2. These are horizontal lines, right? Think about all the points where the y coordinate is 2 form a horizontal line. Okay, this is a line, right? Tilted line of some kind. This is a parabola. Y to the second. It's just, since it's an x here and a y is squared, it's a sideways parabola. That's the only difference. So in fact, let's kind of think about this a bit, right? So if we, this is a line of some kind. In fact, I'm curious what this looks like in a more standard y equals mx plus b form. So let's just get that. Subtract 3y on both sides, so negative. Oh, no. I'm sorry. Well, we're going to want that later anyway. I'm just getting ahead of myself. Let's solve for y, so subtract x on both sides. 3y is equal to negative x plus 2. Divide both sides by 3. Y is equal to negative 1/3 x plus 2/3. Okay, so that's a line, you know, y-intercept 2/3, slope of negative 1/3. Here, let's think of a related picture. So x equals y squared, by the way, would look like this. And you can just check, spot check a couple, you know, pick a y value, right? And see what you get for x. Okay, so if you pick x to be, sorry, if you pick y to be 3, then x should be 9. And so we'll see even from how the picture bows out that the x coordinate is in fact bigger here, right? Now, if we plug in y is negative 3, we'll also get negative 3 quantity squared is x is equal to positive 9. So I hope this is convincing that the picture really does look like this, but then you'll notice there's a minus. So what's x is equal to negative y squared is, okay, instead of the shape this way with positive x values, now x is literally negative what it used to be before, so it looks like that. And then there's a plus 12. So that's a shift, but it's a shift. If the x coordinate grows by 12, it's a shift 12 units to the right, because to the right is where the x coordinate is bigger, right? So we'll have here, you know, roughly speaking, something like that with 12 there. Okay, that's what this is. So if we think of this line, maybe we'll just draw the line in a new color on top of this. So 2/3 is probably, I estimate, somewhere like right over here, right? 2/3 as the y-intercept and a slope of negative 1/3. So rough picture is probably something like this. Okay? And then at some point, this parabola, if we just keep extending it, is going to intersect the line, so one point and a second point. We have to find where those intersections are. And what we're actually really curious about are what are the y coordinates here and here? Because I don't want to draw on these lines yet, because I don't know if here, okay, that 12 was for the x coordinate, but I don't know if the y value here is bigger than -1 or what? You know, is it small? Is this point's y coordinate, is it smaller than -1? Is it down here? So we should figure that out first before trying to draw in some additional stuff. So what are the y coordinates of these intersections? Well, let's set the x is equal. And that's where, so take this is original data, the circle. We can take this, solve for x by subtracting 3y on both sides. So x equals 2 minus 3y, and x, so that's this line in red, but now solve where we've solved for x. Here x is solved for. So let's set the x is equal. So we'll set 2 minus 3y equal to 12 minus y squared. And let's see, quadratic equation, just using the variable y instead of the variable x. So why don't we add y squared to both sides, keep the 3y over here, minus 3 over here, 2 minus 12 equals 10. Okay, so let's see. I hope this factors. Two numbers that multiply to 10. We subtract the numbers. Two numbers that multiply to negative 10. Subtracting the numbers should give you a negative 3. So how about a negative 5 positive 2? Negative 5y positive 2. Yeah, that I think checks out. So we'll have y is equal to 5, y is equal to negative 2. So here, this point, okay, that's the point under the x-axis, right? So this is something for the x-coordinate, negative 2 for the y-coordinate. Over here, this point is something for the x-coordinate. We don't really care. The y-coordinate is 5. And then we were asked, so yeah, there's this region here above the red and sort of on this side of the parabola, but we don't want that entire thing. The way the question is worded is the area between these two and between the lines. So between the lines, y equals negative 1. So sorry, picture, I should have, well, let's update the picture. That often happens, right? So we'll make this more pronounced, give some space. Here's the line, let's say. And then we'll have more room. So here, y coordinate is negative 2, but we want to deal with the line y equals negative 1. So that's like halfway, like right there. So say this line is y is equal to negative 1. Here the y coordinate was 5. So then the line y equals 2 is somewhere down here, a little lower. So what's this? I know it's a lot of stuff, and maybe I should have drawn the x-axis in a different color. I apologize. But the region we're looking for, if we can shade this, should be between these two lines. So, okay, between the parabola and this tilted line, and between these two lines. So this region here. And we'll see, to set up now an integral, now that we've got a more full picture, it's going to be an integral for y values though. So y from negative 1 all the way up to positive 2 of what? Well, imagine you're a point in this region. Let me switch colors here. Okay? If you're a point in the shaded region, you need to do bigger x minus smaller x. So the bigger x value, if you move to the right, is right here. The shading stops on this parabola, whose formula, by the way, was this. So the bigger x, 12 minus y squared, we put here. And then we subtract. Again, if you start here, you move to the left. You end up on this tilted line. So the smaller x, which is given by this, right? So we had solved for x. And so we'll have here minus the quantity 2 minus 3y. Again, the question here was just to set this up. If we wanted the number, we could go through and compute this integral. It's not too bad of an integral, right? No substitutions, for instance, and that kind of thing. Let's take a look at questions 10 and 11. These are for average value. So look at exercise 10. Exercise 10. Okay, average set up but do not evaluate an integral. Okay, average value. So remember the average value for the interval 0 to 2 pi, the width of that interval, 2 pi minus 0. So 1 over the width of the interval, and then integral from the starting x value 0 to the ending x value 2 pi of the function. So 3 to the sine of x dx, and we call it a day. So that is exercise 10. What about exercise 11? Another average value on the interval 3 comma 10. So the average value is 1 over the width of the interval, so 1 over 10 minus 3, width of the entire interval. And then just set up an integral of the function. So integral from 3 to 10 of the given function. So 4 plus x squared over 8 plus x dx. Now if you really want a challenge, that is an integral we can do, so go through it, why not? And this one, oh, yeah, don't work on this one. This one's kind of strange. So we just have it set up. I don't think we talked about the techniques for this. I was going to say, yeah, nope, let's not even say it. I don't think there's much we can do here. All right, call it.